So this is an extension video not required for the power assignment, but may show up on your portfolio and be useful in classes going forward. The question is, okay, you can take sigma notation and write out and calculate the sum. Can you work it in reverse? Can you, given a sum, write out appropriate sigma notation? What makes it a little bit tricky is that there is not one way to do it. There's never only one way to do it. So you've got to make some choices. The choices you need to make are these. Pick a variable. Usually it's going to be an n or an I. That's what's most commonly used. As far as then your second choice, you've got to decide where you want your index to start. Very often we will start at 0 or 1, but you can start with any number you want. And it can vary from case to case as far as what's easiest. So let's do some pattern recognition. Let's start off here with one that's fairly straightforward, adding up the numbers 1, 2, 3, 4, and 5. So step one, pick your index. So when I write out my sigma, and I'm not the best at writing sigmas in the world, but just try your best. Do better than this, though. That is not a sigma. You got to have pointed corners, something like that. So pick your variable. I'm going to use an n. And here's what I know. I've got to end up having 1, 2, 3, 4, 5 different numbers added together. In this case, I think probably the easiest is to say, let's start with n equals 1, and then just add them up till you go to n equals 5, and you're adding your n's. This is the simplest way to write this sum, because you would have 1 plus 2 plus 3 plus 4 plus 5. There you go. This is perfectly good. Now, here's the thing, though. There are other ways to do this. I could get the exact same sum if I did this, right? Put a 0 in. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. It gets you the same sum in the end. You could do all kinds of things if you wanted to. That's what makes it a little bit tricky, is that there's never one right way. So you make your choices. What variable do you want to use, and where do you want to start? Once you've made those choices, then there is one best way to get there. Okay, let's look at the next. I'd like you to do a little pause here and try your best to come up with what the pattern might be, and then write out a summation notation. All right. On this one, spotting the pattern, I hope you're looking down here and seeing, okay, I'm just basically, if I treat this as like a 1 over 1, the top is saying 1 all the time. The bottom is multiplying by 4 every time, right? So 1 times 4 is 4, times 4 is 16, times 4 is 64. So what this really is powers of 4. So I'm going to rewrite this as 1 over 4 to the 0, plus 1 over 4 to the 1, plus 1 over 4 to the 2, plus 1 over 4 to the 3. It's all about locating a structure, because sigma notation depends on structure, some sort of repeated pattern. Spot that, and you're in a good position. So I think here, noticing that the first power I want to use is 0, it's probably going to be easiest to start at 0. The final power I want to use is 3. So from 0 up to 3, I'm going to rewrite that 3, make it just a little bit prettier. And then what I have is 1 over 4 to those powers. So 1 over 4 to the 0 plus 1 over 4 to the 1, the 2, and the 3, and then we stop. Once again, though, this isn't the only way you could have written this. I could have said, well, what if I want to start at 1? Then my power would have to be n minus 1, but it still works out the same way. Put a 1, 2, 3, and 4 in, you get powers of 0, 1, 2, and 3. So in the blue and in the red, they will give you both this series and the same result. It's not that one is right and the other is wrong. It's completely a matter of your preference and what you're using it for. Okay, let's go one more time. Make some choices, spot the structure, So I'm going to use, and actually let's use I just for something different. I for index is a common choice. I want you to first see if you can spot the pattern we're working with. Okay, let's see what we have here. So I see 2 over 5. So it looks like the numerators are alternating and that your denominators are following not a random pattern, but you're going down 2, up 4, down 3, up 5. It's maybe hard to see what's going on until you write it like this. 2 over 5. 1/3 is just 2 over 6. And then 2 over 7. 1/4 is just 2 over 8. And then 1/9 is 2 over 9. Makes it much easier to see, right? Now, we're going to look at this one written 3 different ways. Once starting with an index of 1. So that's where I'm going to start. So what do I see down here? It's always 2 over, and then my denominator just increases by 1 every time. So 2 over. It's now up to me to find a way to make the denominator be 5 if I start with an index of 1. How about I plus 4? That would give me then a denominator of 5, 6, 7, 8, and 9 if I go from I equals 1 up to 5. So I equals 1, 2, 3, 4, and 5 would cover all of those terms. Here is one way to write that summation notation. Which way, if I started at I equals 0 and went up to 4, then what would it look like down here? So take a moment. Did you end up here? This would give us that same series, because if I put in the 0, I'm going to have 2 over 5. If I put in the last one, I'm going to have 2 over 9. Okay, so that still gets us all the same stuff. Very cool. But on this one, I actually think the easiest way is to start with an index somewhere else. I didn't want an equals there. And do this instead. And I want my index is I this time. What should my summation, lower and upper limits, be in order to use this simpler expression inside the sigma? Well, I hope it's not too difficult to convince you. If I want my first term to be 2 over 5, then I need to start with a 5. And if I want my last term to be 2 over 9, I better start with a 9. So the takeaway, once you have identified that structure, in the blue, in the red, in the purple, all of these are fine. It is then just up to you to pick which one you think is best for what your current circumstances are. All things being equal, I generally like to start with an index of 1 or 0, but in this case, it's just so much simpler looking to start at 5 that I would probably choose to start here with 5 and go from 5 to 9.